is why it's much more different. So at any point, if you feel like, hey, Amey, the thing on the slide or what you just said didn't make sense to me. And there's no stupid question. Every question is a good question. So ask me as many questions as possible. You're in a very safe environment. Don't be shy if you want to get the best out of it. As we go through the day, after every 5-10 slides or maybe 15 slides, I'll try to revise everything. So I'll try to create a memory map for you. And during that time, I might ask you questions a little bit. So I'm just giving you sort of a pre-warning that we're going to have that discussions. All right. 2 things. If you want to come off mute, just raise your hand before coming off mute. I do encourage every one of you to come off mute, ask questions. If you have anything, pop it in the chat. If you're shy, it's okay. Okay, pop it in the chat. I'm continuously looking at the chat. So if I'm looking at this side, I'm not ignoring you. This is my other screen. I'm watching the chat here. Okay, with that, let's start networking. The rules are the same from yesterday. If you want break at any point of time, if things are getting a little bit exhausting and a little bit overload of knowledge, just let me know. Just point it in the chat like, hey, Amey, it's too much for me. We want a 15 minutes break at any point. And I'll give a break. So if majority of the people are thinking that way, we can have a break. Okay. Now, for today's lecture, we're going to start with defense in depth. Something you might have heard a lot. We're going to talk about virtual network security. What do we mean by that? We're going to talk about DDoS, something you might have heard before. How do we implement DDoS? Then Azure Firewall, how brilliant it is. How do we implement it? What is VPN force tunneling? And a little bit about UDR and network virtual appliance. Now let's start with defense in depth. Now you might have heard defense in depth a lot of times, but the way I teach, I don't use conventional examples, and the example I'm going to use is a little bit unorthodox. So, before I start defense in depth, I want to ask you just a starter question, just to warm you up a little bit. Have you seen the movie Mission Impossible? Anyone? Has anyone seen Mission Impossible? I think there's a new one coming out in the next 1 month or 2 months. Have you seen the movie Mission Impossible? Anyone? Kitty says yes. Maverick says yes. What about others? Yes, the one with Tom Cruise. You can pop it in the chat. I'm just continuously looking at the chat. Which part? Any part. Any part. Any part is fine. Okay. If you haven't seen Mission Impossible, it's totally fine. Every Mission Impossible movie, it's pretty much the same story. You have Simon Pegg. Yeah, Jay, I know. I'm a big fan too. If you haven't seen Jose, it's fine. You're going to see it right now. So in every Mission Impossible movie, it's pretty much the same story. And I don't want to offend any Mission Impossible or Tom Cruise fans, but it's pretty much the same story. We have Simon Pegg somewhere in the van somewhere. And we have Tom Cruise. Tom Cruise is really good looking, so I'm going to make him good looking. So we have Tom Cruise. I apologize if he doesn't look that good. I'm a big fan too. So one time I got in my comments like, hey, I got really offended. Tom Cruise doesn't look like this. He looks like a guy on a stick. I don't want to offend anyone. I'm a big fan too. I'm not good at drawing. Wait into tall. Okay. All right. So we have Tom Cruise and we have Simon Pegg. And every time it's pretty much the same story. These guys have to steal some data from some data center. And Tom Cruise is on top of the building. So Tom Cruise is always on top of some building and talking to Simon Pegg, who is somewhere in the van. So the idea is they want to steal some data from a data center. So what Tom Cruise does is first he jumps across the buildings gets through the physical security. So all the data center has sort of a physical security, which means they have bodyguards, and Tom Cruise beats up those bodyguards and gets in. Once he gets in, he assumes someone else's identity. So he puts on some face masks, or he puts some eye lenses, which will give him those biometric scans and fingerprints. So he'll get that in. So he assumes someone else's identity. I hope you're still with me. So he puts on those face masks, gets those biometric finger scans or those eye lenses, which give him those eye scans, and he gets in. Once he is inside the data center, which is basically the perimeter layer, this is where you have something called as firewalls. So at the perimeter layer, you have something called as firewalls. I think someone just came off mute. I'm just going to mute that person. I think it's on mute. Okay. So at the perimeter layer, you have something called as firewall. So what Tom Cruise does is it puts in some device, and it gives access to Simon Pegg, who is in a van with his laptop, and he gets access to the firewall. Now, always, I don't know why, there are 3 attempts to log into the firewall. Attempt number 1, I don't know how they guess passwords. Attempt number 1 fails, attempt number 2 fails, and attempt number 3, which is the last attempt, Simon Pegg somehow gets the password right. I don't know how that works. And then he is into the network layer. Now, in the network layer, you have your routers, you have your switches, and these are protected by ACLs and other features and knuckles. So somehow your guy Simon Pegg bypasses them as well, ACL, and gets into the compute side of things. Now, what is compute? Compute means those virtual machines, those container instances or the Kubernetes instances, which are generally protected by endpoint protection, which are pretty much can defend you against any sort of malware or any sort of hacks. But Simon Pegg, being Simon Pegg, will bypass the compute as well, which are the virtual machines and containers, and gets into the application. Now the application, access to the application, which is always so hardened, Simon Pegg gets access to that, and then finally he reaches the data. So every Mission Impossible movie, it is like that. Now, what I want to tell you is this is actually Mission Impossible. This doesn't happen in real life. Why? Because you have a layered approach. So there are tons of layers when it comes to security approach. So as an architect, when you're defining your security environment or you're designing your security architecture, if you use a layered approach, no matter if it's Tom Cruise or Simon Pegg, they can't hack into your network. At physical security, you have your bodyguards and other stuff. At identity level, you have privileged identity management. You have conditional access. You have Azure Active Directory, which will protect from any random person to have or assume your access. At perimeter layer, you have your firewalls. So you have your Azure firewalls. Even if Simon Pegg gets into your network, you have your network security groups, ACLs, and application security groups. Even if it gets to the compute, you have your container security, host security, which as soon as it detects something is suspicious, it will block his access. It will block that lateral movement, and we'll talk about it. Even if it gets into your application. Now, as a security architect, you need to make sure not only that the safe applications, that means only the secure applications are accessible by your employees, you also need to make sure that access to these applications is secure. So you need to harden the access to the application, and you need to make sure only the required applications are whitelisted. So your employees cannot access random applications which are unsecure. And even then, if Tom Cruise or Simon Pegg gets access to the data, they can't do anything with it because the data is supposed to be encrypted. encrypted by either Microsoft managed keys or your keys, customer managed keys. And you can do that using Azure Key Vault as well. So what I mean to say is, if you use a LED approach, if you harden your security posture using a LED approach, it's very hard to hack into your network. It's very, very hard. And at every layer, you need to make sure that there are no loopholes at any level. And we have all seen people joining from Australia in the last 6 months, what has happened and how those hacks have happened in different companies and how devastating they were for each company. I don't want to name names, but even my identity was compromised. And I'm not going back to that vendor again. I stopped dealing with that vendor just because I thought, hey, they're not good with my security stuff. I had to change my photo card, my driver license. I had to take all those steps because I don't want someone else to start assuming my identity and start accessing my TFNs and other things. So have a layered approach, harden every layer. And if you're using Microsoft's ecosystem, as we go through this lecture today, we'll talk about different services you can apply at each layer to harden your security posture. Does that make sense? Are we good? Was that example helpful in understanding a little bit? I know I have funny examples, unorthodox, but I believe unorthodox examples help you learn tech better. So all good? Any questions? Yes? No? All good? Come on. Okay. I want us to be interactive, guys. I'm a bit of an attention seeker. And if people don't talk to me, I feel bad. So just ask me questions. Talk to me. Okay. All right. So next we're going to talk about virtual network security. Richard, we'll talk about that as we go. So what we're going to do is at every layer we're going to talk about different services you can use. We're going to also talk about your key infrastructure and how it's used to encrypt data at each level. And I'll show you that at each level, how you can encrypt data with either Microsoft managed keys or customer managed keys. Good question. All right. Now, next we're going to talk about is virtual network security. Now, before we move into that stuff, this is all, I don't like, one second. There we go. All right, so I'm just going to make a bit of, let me know if you can see my screen. I'm just going to make a bit of an architecture first. Can you see my screen all okay? Can you see the black screen and a white rectangle? It's okay. So let's talk about on-prem stuff and how things work on-prem first, because just like yesterday, I totally believe the way Bhaskar taught us that to learn anything on cloud, it's very important to learn how things are on-prem. So let's talk about on-prem first, and let's take a scenario of an on-prem company, xyz.com. This is my company. Now, every on-prem company has different departments. So they might have a sales department, they might have an HR department, and the most important department in all the companies, because I know we are all part of this department, the IT department. Okay, now all these departments, generally when we are designing a network, they are in different subnets. Does anyone want to tell me what are subnets? Have you ever heard about this term before? What are these subnets? I'm looking at the chat. Sub-networks. Sean says there's sub-networks. Yeah. Okay. Any definition of subnets? I know some of you are from a networking background, so you have to answer. What about others? Have you heard of subnetting before? Come on, let's warm up a little bit. It's not going to be a one-to-many lecture. It's going to be a discussion, many-to-many. Nishant says it's a logical partition of IP. Jan Patrick, I hope I'm saying that right. Jan Patrick, just correct me if I'm not saying. Subdivision of network, Yao says it's IP range subnet. Okay, so basically what I am gathering from you is it's some type of logical division of a network based on IP addresses. So what we do in subnetting is we logically divide the network. We logically divide the network in such a way that one part cannot talk to the other part. So one part of the network cannot talk to the other part. Any benefits of doing this? Any benefits of doing this? Any logical benefits you're seeing? Segregation, okay. ACL, access control list, exactly right. Security. So Jose says it's more secure this way because once sales and HR are in completely different departments or completely different networks, even if for some reason sales gets compromised, doesn't mean that HR department has to get compromised. So you're segregating it, so it's better for security. Separation of access, thank you Nishan. And one more thing, management also gets a bit easier because you're managing different departments. Okay, now these are different subnets. Now all these subnets can talk to each other because sales do need to talk to HR and HR do need to talk to IT. And when I say talk, basically HR do need to sometimes access a shared drive on IT, for example. If I want one subnet to talk to another subnet, what do I need? Is there any device which will help me or any concept which will help me? For two router. Thank you so much. Who was that?
That's Prashant.
Prashant says it's router. What about others? Inter VLAN, so you can do L3 also or L3 switch based routing. Yes. L3 switching. So I'll say routing. So to talk between two different subnets, I need routing, which will be facilitated by a router. Okay. So all the traffic that needs to talk to each other first comes to the router, and it's very similar to the router that you have at your home. So it will go to the router first and then talk to each other. Are you still with me? All good? Now, all of these departments need to talk to this important service, which is called as the internet. So all of them need to talk to this amazing service called as the internet. So before your company's traffic exits to the internet, which device would you use before it exits to the internet? Gateway? Okay, Jose says gateway. What about a secure gateway? NAT, okay. Firewall, thank you so much, Winston. So we need a firewall, and it can be an on-prem firewall, and it can be any vendor. It can be Cisco, can be Fortinet, Palo Alto, whichever you like. So traffic before exiting or entering into your network has to go through this firewall, and then it exits to internet. Now, stuff on cloud works pretty much the same way. Stuff on cloud pretty much works on the same way. Now, in cloud, you have a virtual network, your VNet, Might have heard about this in your AZ-900 or AZ-104, sort of a representation of your network in cloud. So in Azure, we call it VNet. Now the stuff says the concepts remain the same. Concepts remain the same. Traffic that is coming into your virtual network on Azure first goes through something called as an Azure firewall. So you can have an Azure firewall, which we will discuss in detail as we go on. So you can have an Azure firewall. You can have a load balancer behind the firewall. So you can have a load balancer behind the firewall. You can have multiple subnets. You can have a public subnet. You can have a private subnet. So public subnet, you can have your virtual machines which are hosting your company's website. So you can have a public subnet. You have virtual machines which are hosting your company's website, just as an example. So, and load balancer can be load balancing traffic between these virtual machines. So you can have an architecture like that. So you can have a private subnet. Again, the concept of subnet stays the same. Why I need it? Logical division of network. Now the private subnet is not internet accessible and it might host some internal databases, which is maybe your company's employee record, for example. Now this is sort of a logical representation of network in your cloud environment. Amey, is this the only way we do it? In my company, it's not the way we do it. And that's okay. That's okay. This is just a very basic representation of cloud that I wanted to show to you. Very basic representation of network. As we go through the day, things will get a little bit complicated, but a very basic way of doing things. Now, traffic that comes from the internet will first be at the firewall, which will be at a perimeter layer. This is the perimeter layer, the one that faces the internet. So traffic that would be filtered at a perimeter layer will be done by this filter called as firewall. If I want to filter traffic between or within my VNet, what service will I be using? If I want to filter traffic between coming from this subnet to this subnet, anyone? If I want to filter traffic coming from one subnet to the other, what service of Azure will I be using? You might have studied this in AZ-900 or 104 or SC-900.
Is it VLAN?
No. Security group, NSG. NSG. Thank you so much. So NSG is also like a filter, also like a firewall, and we'll see how that works. But if you want to filter traffic within your virtual network, you will use NSG. But if you want to filter traffic coming from your internet, you will be using firewall. Firewall is like a big brother of NSG. It has tons and tons of features. You only use it to filter traffic coming from internet. If you want to filter traffic within your virtual network, just like we have ACLs in our on-prem environment, you have NSGs to filter that traffic. Okay, now we are part of a new world, because whenever it comes to networking, you will never have just a cloud environment. You would always have a hybrid scenario. Richard is asking, I'm confused between NSG and ASG. Richard, that's coming soon, so don't stress. Within the next 30 minutes, I will be talking about NSG and ASG. So just hold on, wait for me. Okay, so we have a hybrid scenario. That means I have my on-prem and my cloud. Now, how do I connect my on-prem to my cloud? There are two ways of doing it. Can you tell me those two ways? Anyone? I want to connect my on-prem to the cloud. What are the two ways of doing it? You can come off mute.
With Azure connector?
No, I'm not talking from an AD. This is all networking stuff now. This is all networking stuff. So someone says, Yao, you're killing it, buddy. Yao says, VPN and express routes. Okay, you guys already know stuff, which is cool. And again, this is so good. Even if you know stuff, do answer it. So it helps you to revise stuff. Once you say that out loud or once you write it, it gets fed into your brain. So even if you know stuff, put it in the chat. So your other friends can also learn from you. Okay. Now let's talk about VPN. Someone said VPN and express routes. What is a VPN and where have you used a VPN recently? I know all of you have used VPNs, some or the other way. Where have you used VPNs?
Firstly, to connect a hybrid environment.
Hybrid environment? Yes. Thank you, Gopinath. Yes.
From branch office or user network.
Exactly. So from branch office to connect office network from home, work device, access company's network, and some people like me who are not happy with Netflix Australia and who want to access Netflix US also use VPN. Have you ever done that? To watch some football matches or get some content across the world? Yes, you do. Same with Prime Mexico. Exactly. So you use VPN, and what are these VPNs? So VPNs are basically an encrypted tunnel over the internet. Encrypted tunnel over the internet. So they are encrypted tunnel over the internet. So what they do is they create an encrypted tunnel over the internet, and we've all used it. So it acts like logically you can connect from your on-prem environment to your cloud environment pretty easily. So this is what it does. It connects your on-prem to cloud or from your home to office or Netflix India to Netflix Australia. If you want to do, Srinivas is asking, can you do that? Yes, using some VPN gateways. Just Google it. It's you can find some stuff on your app store which will help you to do that. So it creates an encrypted tunnel over the internet. Levels of encryption are pretty high, so no random person can hack into your conversation and listen to it. It's very high level of encryptions. Now there are some advantages of doing that, and so there are some disadvantages. Now let's talk about disadvantages first. We've all used VPNs, and have you faced any disadvantages of using VPN? You've all used VPNs. Any disadvantages? Slow. Why? Because bandwidth limited, because your bandwidth is now dependent on your internet service provider. So slow and bandwidth issues, yes. Because it's going over the internet, it's not under your control. Some VPN devices do require licenses, which would cost you, yes. And latency, sometimes, yes. And sometimes, and it's happened with me quite a lot, I don't know if it resonates with you. Amber, I didn't get what you're writing. So sometimes when I basically doing something on-prem, or when I'm logging from my home device, from my home network to my office environment, and I'm doing some changes, very critical changes, and sometimes what happens is, as soon as I'm going to hit that commit, I have some timeouts, so I basically get locked out of my network. And again, I have to log in. I don't know if it has happened with you, but your heart beats twice when you're doing some critical changes and your VPN just timeouts. So these are the disadvantages, but there are some advantages as well. There are some advantages as well. Any advantages? Any advantages? Oh, okay, Amber, I didn't know about that. Secure, okay, because it's highly encrypted. And money, it's cheap. It's cheap because you're using internet's part, so it's super cheap. In the end, it's all about money. So it's super cheap. You are anonymous. You have high levels of encryptions. You have high levels of encryptions. That's right. Okay. Now, one more way of doing it, one more way of connecting it, and someone mentioned it. Was, come on, did I lose my, I just lost my screen. Oh, no, got it back. Now, one more way of doing it is using something called as express route. For those who answered express route, can you tell me how these work? These are basically, they work on a privately leased line connection. So generally what happens is when you have internet, which is from your own like TPG, Vodafone, or whichever network you're using, Telstra network, generally when we are accessing network, we are sharing the bandwidth with everyone, maybe from that suburb or maybe from that building. So we are sharing that bandwidth with someone. But and that makes it slow or that makes it fast. So when no one is accessing, you might get faster speed, but when everyone is accessing, you might get slow speeds. But we don't want that. I'm a rich company and I want dedicated internet connection all the time. So what do? I call my service provider, TPG or Vodafone or Telstra, and I tell them, hey, I want a line just for myself. I don't want to share it with anyone. I just want it for myself. And you can use Azure Express routes on these lease lines to connect to your cloud network. Now, again, there are going to be some advantages and some disadvantages. So talking about advantages, common advantages are going to be, anyone? Super fast, speed, exactly. So you have dedicated bandwidth for yourself, and you have some disadvantages. It's an isolated path from the public. Yeah, that's an advantage. Isolated path. Disadvantages, one, it's not one point of failure. You do it in an active passive scenario, so it's not just one express route. But yes, if the service provider is down, maybe they have an outage, then you lose connection. That's true. But generally it's in an active passive. Disadvantage is super expensive, cost. And as Giri mentioned, if that ISP is down, then you have single point of failure. Yes. Now, disadvantage, one more disadvantage, they are not encrypted by default. You can encrypt using MACsec protocol, which we'll talk about when we talk about express route in detail. You can encrypt it. There are ways to do it. You would need ISP's help to do it. You can encrypt it using MACsec or layer 2 encryption, but they're not encrypted by default. You can do encryptions. Some people also run a VPN over express routes just to make it safer. So layer 3 encryption over express routes just to make it safer. So this is how hybrid scenario is. Now, I just wanted to introduce you to the concepts. Now, as we go through the lecture, we're going to discuss in depth about how an Azure firewall looks like, how NSG looks like, what are public subnets, private subnets, what are VPNs, what are the advantages, express routes. So we're going to look that in depth as we go through the lecture. I just wanted to just sort of warm you up on what we're going to do and how things look like. Okay, any questions? You can take a quick screenshot of this if that helps you. Just take a quick screenshot of that if that helps you. I know for some people it does help. I'm going to wait for yeah.
For express route, what is the maximum bandwidth available?
It really depends on the SKU that you choose. When we discuss about express route, I'll show it to you. There's a slide on that.
Okay.
Okay, any questions? Yes, VPNs are of two types, site to site or point to site. Site to site is when you connect just like an IP site. Point to site is when you give access to one of your admins who will be accessing it from home. So that is point to site. So two types, site to site and point to site. Okay. So you can connect point to site and site to site. Now, if I have another VNet, generally I never have just one VNet. I might have other VNets as well. So this might be just VNet 1 and I might have VNet 2. So if I want to connect VNet 1 to VNet 2, how do I connect it? I can connect them pretty easily using something called as VNet peering. Exactly right. Just wanted to revise and freshen up your concepts from before. So you can connect them using peering. As soon as you create that peering, all the virtual machines from one VNet can start accessing virtual machines from another VNet automatically, unless you apply some policies to prevent that from happening. So you can connect it via VNet peering. You can also use VPN to do it if you want it over the internet as well. So you can connect it something like this as well. So it goes via the internet. What do you want to do it? Richard, we'll talk about private link also. Just give me some time. We've just started. We've just started networking. We'll talk about private links, service endpoints, everything. Okay. All right. Just gonna stop this Blackboard and come back to the slides. Just wanted to introduce some names. Now, before we move on, I want to talk about one more basic concept, which is basically something you might know, but it's important if you don't know. It's called public IP and private IP. Public IP and private IP. Now, what is the difference between these two? Anyone? Why did we come up with this concept of public IP and private IP?
Public IP is used basically to alleviate the capacity issue with IPv4.
Okay, awesome. Thank you so much. So someone said IPv4 is 32 bits. The number of bits you can have is 32 bits. And the number of IPv4 addresses you can have is 2 raised to 32 minus 1, which is around, if I'm not wrong, around 2.4 billion or something IP addresses. If I'm not wrong, not 42, 2.4 billion. Now we humans are around 8-9 billion, and all of us mostly have 3-4 devices, each of which needs an IP address. Now we are still moving to IPv6, but for IPv4, what we said was we'll use something called as public IP and private IP. So if we have 3 companies, for example, company A, and I belong to company A, company B, and company C. Now there is a set of private range IPs. I haven't dedicated, I haven't set it. I'll just put that range on screen as well. Okay. Where is my private IP range? Yeah, there we go. So there is a range of private IPs which the Internet Authority said that, hey, this is going to be used as private range. I didn't come up with this. They said this range can be used within or inside a company. So if I belong to company A, Giri belongs to company B, and Sean belongs to company C, what I mean is all of us within a company can have 192.168.1.1, 192.168.1.1, 198.168.1. Now, the problem is what happens if I want to access a public website, for example, gold.com, and I want to just see who won the Champions League last week. And I want to see that, and all of us are big football fans, and we want to see. So I'm requesting this to gold.com, which is probably at a public IP range of 201.1. So all of us are requesting the same content. Now, problem is who will gold.com respond to? Now, it doesn't happen this way. Private IPs are not internet routable. So they are not internet routable. You can't use private IPs to communicate with the internet because anyone can have private IP. So all of us, if we talk to gold.com to check scores, gold.com doesn't know who to send back the reply to. So these are not internet routable. That means the ISPs don't have a route for your private IP. Private IP should not be exposed or advertised to the internet. Never. Okay. Even if you do, the ISPs block it. So 192.168.1.1 needs to be converted to a public IP. Every company has set of public IP addresses. Public IP addresses are paid and are expensive. Private IP addresses are free. Public are paid. So whenever I want to talk to a public website, I first need to convert my IP into a public IP. Which service helps me do that? NATing. So using NATing, I convert my private IP to public IP. Does that make sense? So I need this service called as NAT, Network Address Translators. So basically convert a private to a public before they talk to internet, and then they reply back to this IP, which gets converted back to it. Now this is known as source NATing or SNATing when you're converting from private to a public to talk to gold.com. Does that make sense to everyone? Can I get a quick thumbs up from everyone? Is it good? Any questions? Because I will be using NATing all the time. I just wanted to explain you what NATing does. Okay, so this is known as SNATing. So SNATing means basically source NATing. You can also have something called as a DNATing. So for example, I am working from home and I want to access a private server, which is probably on this IP address. If I want to access it, I can access using DNATing, which basically is the opposite. So this is private to public. This is public to private. So it goes something like this. So I go over the internet. If this is my internet, I log in using that public IP over the internet. Basically, I log into this 200.1.1 and I get access. It basically forwards my request to this server. So this is just opposite of SNATing. The concept remains the same, but this is known as DNAT. When I'm trying to access a private IP server within my company using a public IP. So my traffic is now basically flowing from the internet to this IP, and the IP will basically forward it to this. You can call it IP forwarding, DNATing, whatever you want to call it. So the concept remains the same. Public to private, private to public. Okay. So I'll be using the concept DNATing and SNATing pretty often. Just wanted to introduce that. Okay. Coming back. Now let's talk about DDoS. Let's talk about distributed denial of service attack. Now, the goal of DDoS is basically to prevent any sort of legitimate user from accessing anything. For example, I have a router on-prem or a switch, any server on-prem, and I need to access this router. I access port number 22 or port 21, which are the ports for Telnet and SSL, or 3389 or RDPing into the server. So what hackers do is they generate a lot of traffic. From legitimate IPs. They generate a lot of traffic on these ports from legitimate IPs. They generate so much traffic on these ports for a router or a switch that they overwhelm the port. They overwhelm the port so much that a legitimate user, which is me, who wants to basically log into this router and switch to do my job, I cannot access this switch anymore. Why? Because hackers have overwhelmed this particular port. This is known as denial of service or a DDoS attacks, where your attacker generates large amount of legitimate looking request on this port. By doing so, they make sure that a legitimate person who is actually supposed to log into this company and do his job, he doesn't have access to this service anymore. Now he does this using something called as botnets. Botnets are a collection of internet connected systems that individual controls and uses without their knowledge. So they basically put botnets on each one of your computers, on legitimate users' computers, and they can be done using phishing or other attacks. They put this botnet softwares, malwares into your computer, and then they generate this sort of attack. Now, DDoS is a collection of attack types aimed at disrupting the availability of the target. So for me, who's a legitimate user, I don't have access to my network anymore. Now you can stop DDoS. Using Azure as well. So using Azure, we have DDoS implementations. So you can start using Azure DDoS and stop these type of attacks. Now, DDoS protection standards monitors the actual traffic utilization and constantly compares it against the threshold defined in DDoS policy. When the threshold is exceeded, DDoS mitigation is automatically initiated. When the traffic returns to normal levels below the threshold, the mitigation is removed. Now, DDoS in Azure comes in two SKUs. Does anyone know what SKU is? Anyone knows what SKU is? No? It's actually a stock keeping unit, but you can imagine these as two flavors, multiple flavors or multiple products. So there are two types of offerings, flavors or offering, or in different slang in different companies. So it comes in two offerings. Either it's DDoS IP protection or DDoS network protection. So the difference between the two is network protection will protect your entire network. So it gives you enhanced DDoS mitigation features to prevent any sort of attacks over the entire network. And these are expensive. But what if you don't want to protect the entire network? You want to protect a single IP, a single public IP service, like one load balancer, which has a public IP, or one application gateway, which has a public IP. You don't want to protect the entire network. In that case, you use an IP protection. Let me show this to you, how to do it on the portal. So if I'm on my portal, if I want to do DDoS, so just search. In Azure, the good thing is, whatever you are looking for, or what I mean is whatever the service is, it is actually called by the same name, not like EC2 or any random names. virtual machine is called a virtual machine, DDoS is called a DDoS. So you can create a DDoS protection plan. You can create a DDoS protection plan. Pretty easy to do it. I've created one for us. So you just put the resource group, give it a name, and just review and create. It does take a couple of minutes to get started with. Now, once it's started, it looks something like this. It looks something like this. So you can give access using IAM, something which Bhaskar discussed yesterday, where you can give specific people to play around with DDoS protection plan, some role-based accesses. Now, the thing that we're interested in is the protected resources. So I can either protect my virtual network or I can protect specific IP-based resources. Or I can just protect a firewall, or I can just protect an application kit. I can just protect a bastion host. But if I want to protect the entire virtual network, I have to add the entire virtual network. And it's pretty easy to do it. Just add the entire virtual network. Now, let's look at the pricing. I just want to show you the pricing. Now, as you might have guessed, if you look at network protection, the price is pretty high, but it protects over 100 public IP resources. So the price is around $3,000 a month in US. And if you just want to protect one IP address, just one resource, then the price is $199 a month. So these are important if you're a solution architect. So I've just put it in the chat as well. Okay. Now, DDoS protection prevents any sort of volumetric attacks. When I say volumetric attacks, means any sort of UDP flood attacks, application flood attacks, spoofed packets attacks. It can prevent any protocol attack like SIM flood attacks or reflection attacks, or it can protect you from any application layer attacks as well, like any sort of layer 7 SQL injection, cross-site scripting attacks, because it checks for malformed packets and any sort of spoofing. It is backed up by Microsoft Threat Intelligence, which is backed up by Microsoft AI. So it will keep looking at that and basically protect your network. Now I have a couple of questions. Shinema says, why would someone choose IP protection over network protection? Now, many customers just have one gateway, or everything has one bastion service. So they just want to protect one particular public IP, and they don't want to protect the whole network because everything else is inside that network. Nothing has a public IP, only the bastion has a public IP. So you just want to protect one IP. So why would you pay $3,000 to that? You just protect one IP. As Gopinath mentions, just the gateway. Now, how can it identify the attack? As I mentioned, it keeps monitoring. It keeps monitoring for legitimate requests. It keeps monitoring for any sort of utilizations. So it keeps comparing actual traffic. I mean, the normal traffic, the everyday traffic versus any anomaly detected. So as soon as it detects any anomaly, like, hey, things are not making sense. I'm getting so many requests which I never get from. So it's like, hey, something's wrong, and it will block that port automatically. Try to block that attack automatically. Again, this is all powered by Microsoft Threat Intelligence, which is powered by Microsoft AI. And AI is right now with Microsoft, they're doing really well. Yes. Okay. Now, next we're going to talk about is Azure firewalls. At any time, guys, if you think, hey, Amir, you're going too fast, can you go a bit slow? I'll go a bit slow. If you say, hey, Amir, can you repeat this concept again? I'll repeat that concept again. So just let me know. I'm very flexible. At any point, if you think I need a break, just let me know. Okay, are we good until this point? Any doubts until this point before I start talking about firewalls? Are we good? Amber says yes. Sean says yes. Others, Yao, Jan, Kiri, Patrick, all good? Okay. All right. Are you having fun? Having fun is also important. We're just not, it's not, I don't want to make it boring. I want you to basically enjoy this as well. So I hope you're having fun as well. Okay. You might be thinking, hey, who has fun learning about firewalls? Some people do. And if not, it's my job to make it fun. Yes. Okay. All right. Now next we talk about firewalls for the next 30 minutes and then we'll go for our small break. So after 30 minutes, we'll go for our small break. Now let's talk about Azure firewalls. Now Azure firewalls, which layer do we implement Azure firewalls on? Do we implement it at network layer? Do we implement it at a perimeter layer? Look at think of the difference in depth chart.